Section 14E, question number 3, page 357. In this question we are to find dy by dx from first principles, given that y equals 4 minus x for part A. So this is just done by using the limit notation of the limit definition of the derivative, or finding the derivative from first principles, just as we would in function notation, but now we're using Leibniz notation. So we've got the limit, and I'll just substitute this right in here. So I've got 4 minus x plus h minus, in the brackets, 4 minus x all over x plus h minus x as h approaches 0. Again, the x and negative x will cancel from the denominator. We'll leave the limit notation here, and then we've got 4 minus x minus h minus 4 plus x all over h. 4 minus 4 disappear, negative x plus x disappear, so we're left with the limit of negative h over h as h approaches 0. We can simplify this to give us negative 1. So the limit of negative 1 as h approaches 0 gives us the derivative dy by dx equals negative 1. 3b, so we require a little bit more room here, so I'm going to switch over to a new page. So the function now is y equals 2x squared plus x minus 1. So dy by dx equals the limit of 2x plus h squared plus x plus h minus 1 minus 2x squared plus x minus 1 all over h as h approaches 0. So in proper form, we'll leave the limit notation. I'll expand this out, x squared plus 2xh plus h squared plus x plus h minus 1 minus 2x squared minus x plus 1 all over h. Now I'll multiply this 2 in, and just carry everything else forward from the previous line, and then I'll see what I can cancel out here. So I've got negative 2x squared here and a positive 2x squared there. I've got a positive x and a negative x, negative 1 and a positive 1, so all those just disappear on us. So we're left with the limit of 4xh plus 2h squared plus h all over h as h approaches 0. And then factor out an h. We're left with 4x plus 1 plus 2h all over h. These two h's will cancel. We're left with now the limit of 4x plus 1 plus 2h as h approaches 0. We substitute the 0 into the formula, and we get dy by dx equals 4x plus 1. Slide down here to part C. Now things are a little bit more interesting. I might actually have to write much smaller in order for everything to fit on the page. Y equals x cubed minus 2x squared plus 3. So dy by dx equals the limit of x plus h cubed minus 2x plus h squared plus 3 minus x cubed minus 2x squared plus 3 all over h, I guess technically is x plus h minus x, where those disappear, as h approaches 0. Here's where the microscopic writing may come into play. So I will write as small as I can here to allow it all to fit. So I got x cubed plus 3x squared h plus 3xh squared plus h cubed minus 2x squared plus 2xh plus h squared plus 3, and then I'll multiply this negative in, negative x cubed plus 2x squared minus 3. And this is all over h. Correct that 3 there. And now I'll expand in this negative 2 into this bracket, and then begin doing some simplification. So this is x cubed. I'll just write all this stuff out here. So negative 2x squared minus 4xh minus 2h squared. And then just carry on with the rest of this. All over h. And now I'll begin to do some of this cancelling here. X cubed minus x cubed, negative 3 plus 3, 2x squared minus 2x squared. And every other term has an h in it, which is good. And so just write that out, 3x squared h plus 3xh squared plus h cubed minus 4xh minus 2h squared all over h. And then I'll factor out an h, 3x squared plus 3xh plus h squared minus 4x minus 2h all over h. H is cancelled. And then we're left with 3x squared minus 4x plus 3xh plus h squared minus 2h. Oops, not over anything actually, sorry. Excuse me. Now I will substitute in the 0, and therefore dy by dx equals 3x squared minus 4x. Because that goes to 0, this term goes to 0, and so does this. So that is the final derivative from first principles of the function y equals x cubed minus 2x squared plus 3.